I'm Benny D, and in this video we're going to look at the surface area of composite shapes. Okay, so when we look at our surface area of shapes, we're talking about how much does all the areas of our shapes around the outside add together. So we can start off with some basic ones to begin with, which could be, for example, a pyramid. Okay, and we're going to say that we've got dimensions of 3 meters and 3 meters. Now this is the one that's a little bit tricky. Okay, in this, we keep saying about the height being from the tip down to the center of the base. Okay, well, in this case, we actually need the height, or the distance, sorry, from the top of our point down the face of our pyramid, down one of those sides, okay, to the middle of our triangle here, or the middle of our base of a triangle there. Because in reality, if we think about what a pyramid is, okay, if we were to unfold it, if you could do that, okay, it's going to be a square with 4 triangles on it. Okay, and we know that to find the area of a triangle, we need this height of our triangle there, which is actually the distance down the face of our pyramid. Okay, so what we need to do there, okay, is decide what that dimension is going to be, which is, in this case, let's go, oh, sorry, that one was going to be 3 meters. Let's make this one 5 meters. Okay, so if we've unfolded our net like that, we can say, well, this is 5, and both these are 3, and each of these triangles must be the same. So when we're looking at our surface area, okay, what we do is we go, well, let's look at our components. Well, I've got 4 triangles, so I have 4 of them, okay, and each triangle has an area of a half, because this is our formula, half base times height, so half times 3 times 5. Okay, and we're going to need to add to that the area of our base, which is 3 times 3. So when you look at that, well, 4 times a half is 2, times 3 is 6, times 5 is 30, plus 3 times 3 is 9. So overall, this would have a total surface area of 39 meters squared. So got to be careful here. It's very easy to slip up and make that meters cubed, but we're not finding the volume, even though it's a 3D shape, we're finding the 2D area of all of its sides. Okay. So if we have a look at another one that's always an important one, which is the surface area of a cylinder. Okay, so we have a look here at a cylinder that we've got. Okay, it needs to have some sort of a radius at the top. Let's say that's 3 centimeters. It needs to have a height, which let's call that 10 centimeters. Okay, so what we need to do for our surface area, okay, is realize, well, we've got the top and the bottom, because we've got a bottom here that we've got to worry about as well. So that's going to be 2 circles. Okay, 2 circles the same. Okay, so I know I've got 2 of them, and I know the area of each one is pi r squared. Okay, I know I've got that. Plus we need the area around our cylinder. Now, the way to think about this is if you had a can of baked beans and you took off the label, okay, and you unrolled it from the tin, okay, that is going to represent the surface area of that tin. Okay, it's actually going to be a rectangle, okay, when it unrolls off it. The height is going to be 10 centimeters of it, because that's what we found here. That's going to be this length here, but then we're going, well, what is this length? How long is this? Well, it's actually the same as the circumference of our circle, or our distance around the top of our cylinder here. Right? And we've got a formula for that. Okay? We have spoken about in a previous video on the area of circles, which we spoke about some properties, but if you can't remember, that's okay. The circumference is really just the perimeter of a circle, and it's equal to 2 times pi times the radius. Right? So we can add that on here, that we can say that now we've got 2 times pi times the radius. Okay, so we can work all this out now, what we need. So we're going to have 2 times 3.14 times our radius, which was 3, and that's squared, so it's going to be times by itself. Then we're going to add on 2 times our 3.14, that value of pi we're going to use, times our radius, which is also 3. Okay, so we can work through this a little bit. 3 times 3 is 9, times 2 is 18. So 18 times 3.14, plus, we've got 2 times 3 is 6, so 6 times 3.14. Okay. If we've got 18 times 3.14 plus another 6 times 3.14, well, we can say all that we've got 24 lots of 3.14. Okay. Well, if I round this to 25, 25 times 3 is 75. So I know that 24 times 3 is going to be 72. And we've got to do that extra 0.14 onto it. So it's going to be around about, okay, 75 centimetres squared. Okay, remember, because we're using pi and we're using that approximation, this is only an approximate answer. You need your calculator to help you out and get the exact answer for that. Okay. Now we can do some things though. Okay, we need to be careful. Okay, I'm not going to work through the full example with this. Okay, but you just need to consider if you're doing other shapes. Okay, there's lots of different things we could do that you need to be careful about. Okay, trying to find the surface area. I'll try and draw this somewhat. Okay. Actually, I'll just draw it from top down. That might be a little bit easier. So from top down, what I'm thinking, right, is I've actually got a box. Again, you can kind of think of this like something you might see in a skate park or something like that. Okay. So this central part, okay, is a flat top. Okay, these are ramps coming up to that flat top from each side. Okay, and then we've got triangle sections that also slope up. So it slopes up all the way around. Okay, so you can see here, like it's a cool design, okay, but there's a bit more to it. So we're going to have multiple edges that we've got to consider, or faces we've got to consider to be able to work our area out for, different things like that. Okay, you could be doing something like, well, for a skate park, you could have well, if we start off with thinking about, we've got a couple of quarter pipes, okay, making up a half pipe. They just spread out a little bit. Okay, well, we start to, and we think this is 3D, and this, like you said, a skate park, if we're doing something like this, okay, this starts to get a bit more complicated, okay, because we've got a rectangle here, if you like, that's had part of a circle taken away from it, okay, and all sorts of different faces that we've got to work with. So you can see the surface areas can build up pretty quickly to be something a bit more complicated, but the trick is you just need to work through it in a really logical way, okay, breaking it down into its parts and working through each part separately. Okay, so hopefully that gives you a bit of an idea of what you can do there.